Okay, so now it's 10 a.m. and as we planned, we already have lots of viewers in YouTube and also Zoom participants. So let's get started. So today is the third consciousness talks, and the first speaker today is Shigeki Nakauchi, and he's going to talk about color appearance in dichromats. And then followed by that, Shin'ya Nishida is going to talk about, maybe the title is no longer tentative, I guess. So I'll just remove. And the color is not only for color Qualia. So this is great talks, and it came out of the discussion after Color Qualia Symposium, which Qualia Structure organized in March. So if you're interested along this discussion, please watch the symposium as well. And you're free to ask questions in Zoom, and also we also take the question from YouTube as well, if there is any. And the format is because we want to facilitate the discussion and the collaborations within the Asia Pacific regions on consciousness research, we asked speakers to be relatively brief on their own talk, roughly like 5 to 10 minutes, and then so that participants can ask lots of questions afterwards. And then per person, roughly 30 minutes. But if the question never ends, then we can make it longer, as long as speakers are fine with it. So here's there is a slide for this talk, and I'm going to paste it on the chat and also YouTube link. But here you can look at the abstract of Shigeki's talk and also bio, and similarly for Shin'ya. Just briefly, Shigeki is a professor in Toyohashi University in Japan, and his research interest is on human color. And that's it. Please go ahead, and I'll share the screen.
Okay, thank you, Nao-san. I'm very glad to have this opportunity to give my talk on the appearance of the color dichromat. But actually, this happens because I found the Nao-san is writing was saying that the question about Nao-san yellow is the same as others yellow, something like that. That is a everybody, even the doing the color science, are interested in, but we have learned that that is impossible. The textbook saying so, but the Nao-san is now the leader, leading consciousness research, and I expect, now it's possible to do discussion about that. So today, I just briefly give about that appearance, color appearance of diagram. Okay, so before going to the main body of my talk, I just want to mention about the definition of color. And you can see the textbook, that is a kind of Bible for the color vision people. In that book, it says the color is that aspect of visual perception. This is okay. By which an observer may distinguish differences between two structure-free field of view of the same size and shape. And I might add some surface quality or something like that. And this definition says nothing, but I have to say, I think there is no other way to define the color. And we remember that neuroaesthetics, for example, this is possible without definition of the sense of beauty. So we can do the science without any exact definition of color or beauty or attractiveness, something. That is the ordinary or traditional way of that. And instead, we do the color science based on the very, from three measurements. One is a color matching, to find the visual equivalence. That is the scientific basis for colorimetry, which stimuli, a pair of stimuli looks similar, something like that. And by doing this, we got color matching function, and based on color matching function, we can build color space to describe the colors. And another one is the visual threshold. This is very basic for the science physics, as all of you know that. And that describes the probability of seeing a difference in a pair of colors. And based on that, for example, this is a very famous McCallum ellipsis. That ellipsis sees that region of color looks similar. And depending on the colorimetric coordinate, that space differ, changing. That is the McCallum ellipsis. So both are measured from the observer's responses to a pair of colors. And I think this is very typical on the color. We can do the color naming experiment. In that experiment, we ask the observers to name colors of given stimuli. I think this is very specific for the color vision because you can do the orientation or shape, but you usually do not do the name of the orientation. Of course, horizontal or vertical, that is specific, but color, because of the categorical nature of color, we often do that color naming experiment. And as you can see, or you may see, you may know that the human do the several color names to describe the stimuli, pink, yellow, green, blue, purple, things like that. And also it was known that the chimpanzee have a similar categorical nature of the color, and it looks similar. Often argued about that. And the color name reflect the categorical nature of that, just remember that, but not Qualia in that sense. Then again, so we can do the matching experiment and from the two observers, for example, and these data are comparable, and threshold data, of course, that are comparable for across the observers. And even for the naming response, red or yellow, that is comparable. That textbook or color vision textbook said that. Then how about the Qualia? Perceptual experience or appearance, is that comparable or incomparable? That is the question. And according to the textbook, we do not ask that question. So we have been doing no such experiment, right? Then, but of course, many of the color vision researchers are very much interested in the appearance, and especially for the dichromat or colorblind people, how the colorblind people see the world. And John Dalton did, this is a very famous story, and he wrote some description here in his diary, and like the flowers pink, but it appeared to me almost an exact sky blue by day, something like that. And this is known that this is the historically first scientific description about the colorblind. And interestingly, after the 200 years later, since the writing this diary, Dalton was supposed to be a tutelary by the gene analysis, and presented in Manchester, the hometown of Dalton. I was attending that conference, and according to the simulation, as I explained later, actually this pinkish flower tend to be a bluish, and if so, the Dalton's description seemed to be very correct. Okay. And the principle of the colorblind people appearance simulation is very simple. That simulation is done by the mapping the normal color onto corresponding color of the four color dipole colorblind people. In three-dimensional color space for the normal color vision people, squeeze it into a 2D plane. Or when we focus on the colors, excluding lightness or luminance dimension, these color, color plane map onto line 1D single colors. Then we got this kind of simulation. For the normal color vision, people see the apple looks like red and banana looks like yellow, but for protanol, but deuteranol, but tritanol looks that colors. And the people believe that because nowadays so many softwares are available, even for the Chrome web browser. You can add some apps on that web browser to simulate the colorblind people, and Adobe with Photoshop also have that toolbox, right? But again, how can we find the corresponding colors between normal color vision people and the dichromat color vision? Because color vision textbook says it is impossible because it is incomparable between the normal color vision people's appearance and the appearance for the colorblind people. But it is also historically very important. There are unilateral color vision people. That means the people who has normal color eye and other eye is the colorblind. So that people can directly compare the color appearance in one eye of the normal color and one eye of the colorblind. And that's the Judd observation, the very old, more than 50 years ago. He said that it is impossible usually to discover what colors are seen by colorblind people, but it is possible if we have a unilateral color vision observer to discover how the color perceptions of the colorblind are related to those of the normal color observer. Okay, and what is his observation? Is okay. So roughly saying, there are four important observations. If the colorblind people see the spectrum, then he found this probably it's better to use the even in the spectrum, the colorblind people see the white around the 5 nanometer. And this region of the monochrome light looks yellowish, and these are bluish. Okay, and this is yellow. And most important things is white in normal eye looks also white in colorblind. And based on these observations, all kind of the sort of the simulation can find the colorblind people simulation. But another issue is that the phenomenologically dichromats can name color actually as good as normal lighting, even though they cannot accurately discriminate among red-green hues. There are a huge report about that. And actually, we have done the similar things to ask dichromat people to name the color chips shown here, and ask them to name freely, but without not allowed to use a combination of color like a greenish blue or greenish yellow, green, yellow, pink, sky blue, something like that. Okay. Then for normal color observer, we got this kind of data, naming color, naming result. These tips, okay, I do not explain details, but normal color observer named green, yellow, red, purple, blue. And for protanobes and the deuteranobes, the color naming result, probably you agree that mostly the same as the normal observer. Of course, we measure the color threshold data. We confirm that their threshold fold along the red-green axis are very large. That means that they are very much not good at discriminate along that stretch. But they can name green or red. Okay. Then that's the discrepancy of that. So dichromacy colors are normal to trichromat do. That is another question. So then we are doing some tricky experiment. Actually, another research project, we have developed some filters, spectral transmittance filters, and of which spectral transmittance was designed so as to optically simulate, not the computer simulation, optically simulate the similarity among the colors perceived by dichrome. That is predicted by the Brettel simulation. And according to the theoretical design, we actually physically manufacture the optical filter like that. And without filter, we see the Ishihara plate. You can see if you have a normal color vision, you can see the 8 digit on that. And through the filter, you can see the bluish color here, and you may see the digit 3 on that. That's a typical, Ishihara plate simulation. And the filter can mimic that. Okay. Then this is, okay, I will skip. And in principle, through that filter, the red-green color opponent signal are weakened or diminished to simulate the color blind appearance. Okay. What happened to dichromats naming result when the colorblind people appear have that filter? Then we do the similar results. This is for the naming result from the normals. Of course, as we expect, the naming response from the naming response color red or green, something like that, orange, disappeared after wearing the filter. Of course, this is what we expected, and actually we designed to do so, right? But for the colorblind people, without filter, they can do very accurately name, and even after wearing that glasses, for protanope people, they can name the red, but they can name the green. For the deutan, also red and green. So naming response of red and green remain for that. So this is the last slide. So what we observed in our experiment, so without filter, the dichromat people and the normal people seeing the same apple, for example, and the normal people named as red. And probably they have a reddish, the Qualia. But dichromat people also seeing the same object and the same naming response, but the question is how that colorblind people see it. We're asking the Qualia, but we didn't know about it. And after wearing having the glasses, normal people, for example, the name as yellow, and probably they see the yellowish color they have. But dichrome people named the red. But still, what color they see is open question. But we can say that dichromat people name the same red, so probably this Qualia should be the same, and probably different from the normal color. But again, I want to say that what if they are red remains as an open question. Okay, that's all my talk. Thank you.
Thank you very much for thought-provoking presentation. And let's move on to our discussion and a question. Does anybody have any question? If not, then maybe I can take advantage of my chair position and then ask the question first. So I think you started out the very nice definition and the background introducing color. And also how psychophysicists have been investigating color qualia through matching and threshold and naming. And then it came to, when it came to the term appearance, then things started to become kind of unclear. And it's always, I'm not a professional psychophysicist, so I have to confess that. But the appearance always sounds to me the kind of the euphemism or secret word used within the psychophysicists to avoid the term qualia. But what you are talking as with appearance is about really qualia, right?
Yeah, that's right.
Yeah. So then people do study appearance, and through many different kind of ways. And one of the things that I think was striking to me when you are citing Dalton's, it is mainly we start to understand that maybe there's some people experience the color differently from, your own through the description of many experiences or through the relationships.
Yes, yeah.
Like the case was like this pansy, pink, like blue sky. And basically what I'm proposing is through this type of this relational characterization, we may be able to understand what other people are experiencing much better than the previous way of, just a discrete kind of measurement of the threshold and so on. Maybe I'll stop here. But what do you think?
Oh, okay. So I have seen so many YouTube video you are mentioning about the similarity structure relation.
Right.
And of course, the basic science of the basic science, the color vision people also trying to describe the relationship of the color perception.
Yes.
But of course, we have very much motivated to say something about the appearance. Even you say the appearance is very vague and very ambiguous. But the color vision people usually describe, appearance as, for example, this color is reddish component is 60% and the yellowish component should be the 20%, something like that. That is known as a basic color component method or something like that. So, I mean, appearance also try to describe some quantitatively. But of course, I partly agree with your, your opinion about that.
I mean,
okay. And the relationship, that is very important. But relationship, I just remember the MDS. MDS is multidimensional scaling is the preserve the relationship structure of the pair of stimuli, right? But that relationship is...
But it's typically, ignoring the fact that, two-dimensional solution is never complete.
So
I think that will relate to Nishida-san's talk next, but yeah, so I don't think, color is completely two-dimensional or three-dimensional kind of structure, but go on.
But
Yeah.
I want to say that it's that relation is even the preserved if you rotate that high dimensional space, right? Or if you move the parallel. But so I mean that if you flip everything of the hue in the natural scene, for example, the relation is preserved, but looks very, very different and looks probably very unnatural. So relation is preserved, and relation is very important, but some absolute, how to say, sense or absolute Qualia, not Qualia, but absolute value is also very important for the color vision. Color vision people believe that.
Yeah, because there are two more questions, I'll be brief, but I think what we are proposing is not the relationship within color only, but the color has to be also related to many different things, and probably Nishida-san's talk is talking about the color and the structure and the texture, or many different kind of background condition as well as the shape and the reflectance. And many things has to be also related. And when the things becomes very multidimensional and asymmetric, then you start to not to be able to flip the axis or rotate and things like that. That's my kind of idea. But maybe I'll stop here. Yeah. And then let's get two questions. Ariel, do you want to ask a question?
Yeah, I'll go for it. Thanks for the talk. That was really interesting. My question is about how we use the term correspondence between normal color vision or typical color vision and people with color vision impairments. And we talk about how we expect like a compression of like their three-dimensional color space to a two-dimensional color space, and that there might be some correspondence between three-dimensional color and two-dimensional color. What interests me is there's a paper from Boston in 2005 about color space in deuteranopes where they're able to discriminate colors that people with typical color vision can't discriminate. And how would we imagine the correspondence works the other way? Are we imagining that then these deuteranopes have colors that people with typical color can't see, or that somehow the colors we see are just switched around for the colors they can see? Or does the field just like not weigh in on that question at all?
Yeah, that's interesting. And actually corresponding can stand only in the just unilateral color vision people. So they can directly compare that. So I just use the corresponding color. But the question is how can we compare the colors across the observers? So how say? But we believe that if you have the both side, you are both sides are colorblind, other people have both sides the color normal. And if it is possible to compare, if you can exchange your eyes with the other eyes, then what color you see? In that sense, I just use the corresponding color. But this is still ambiguous and still questionable. But yeah, thank you very much. That's a very interesting question.
Thanks.
Okay, Yota.
Yes, thanks for your interesting talk. I have a question about learning, the difference in learning between dichromats and healthy subjects. So the reason why I want to ask is that maybe the dichromat people are, in a sense, forced to name the color as a healthy subject do. On the other hand, the healthy subject did not have that kind of learning experience when wearing your devices. So my question is, did you consider the difference, and is it possible to remove the effect or something?
Okay, so of course our final conclusion is dichromats have learned the different mapping from the color appearance or color qualia to the name level of the language, and that can be acquired a very long, time, years. But I do not say anything about how they can learn about that. One possible way is that if you appear that you have a spectral filter for the normal color vision people and continue to wear the couple of years, and it is for, and then we can examine the mapping from the color appearance to the name language level are changed after the couple of years or a couple of days, something like that. But I haven't done that kind of experiment yet. But of course, that mapping is different from the normal color vision people, and that of course essentially acquired after the birth, I think. But
Okay.
yeah.
Thanks.
Nishida-san?
Just a clarification question, and I just wonder what happened when you use the uniform field, whole field stimulus with no spatial context, and whether dichroma is still able to make a discrimination, and also you change the intensity. So I mean that any spatial cue or intensity cues are excluded, and still they can do it. And is there any attempt to see to do that kind of experiment?
No, and you mean the dichromats can name the color?
For naming or that part, yes.
Actually, I haven't done that kind of experiment, and I believe they partially available do that. I'm not sure. And even for the normal color vision people, if you dive into the very uniform color field, every color are faded very rapidly and seem to be difficult to name that color, even for the normal color vision people. So I'm not sure what happened on the dichromat people, but I think very similar tendency will be the found also the dichromat. Actually, I haven't done that kind of experiment. Yes.
Thank you.
Just to sort of follow up some of the part of the question Ariel asked. So you are probably familiar with the Boston's paper, right, in 2005 Current Biology, where when the researcher actually generated a substance that is optimized for this deuteronome sensitivity, then I don't know whether they actually asked them whether they discriminated this consciously or not. So that part is still a question. But if they are actually able to discriminate what we cannot, then that seems to at least provide plausibility that in our brain, which you haven't actually mentioned at all today's talk. Let's say I'm not saying that there is a color center in D4 or D8, but let's suppose that something like the mechanism that generates color qualia is in the brain, and if that is more or less the same, maybe through as Yotta suggested, through the learning and experience of those color blind or color weak people have a different connectivity in this color areas, but it's also plausible that through the learning and so on, they may be able to pick up the slight difference that we usually don't pick up, and then eventually generate a very similar topology, very similar neural connectivity pattern within the color areas in their brain. So input at the level of their eye may be reduced or changed quite a bit, but eventual color brain areas may be not that dissimilar to us. Do you think that's a possibility?
Or is there any kind of study that look at local connectivity patterns of the color areas between the colorblind versus normal?
No, I don't know that the evidence for the precise the anatomical difference between the normal and colorblind people, and I can understand what are you saying. So if we can compare the some microstructures activity, both the normal and colorblind people, and probably the activity patterns are not so dramatically different, both. But based on that observation, is that possible to conclude so the color appearance or color qualia for the normal and the colorblind people are similar? Is that possible to conclude that? So that is the stick my mind. So is that possible or not? Of course,
so
we can.
okay. So this is my opinion and my kind of long-term goal, but the comparing the two persons' experience is not possible. We can get a lot of a good guess about how they are experiencing by looking at the relationships and so on, and also including the manipulation that you did with the glass. These kind of things are very, very powerful tool to do that. But eventually we need to go to brain and also extract the brain from relevant information structure through some kind of theory, such as IIT or something like that I've been proposing. And then at that level, if this is the same, and if this theory part is correct, if we can establish that, then indirectly we should be able to conclude that this person and this person is experiencing something similar or different.
So including everything, I mean, including not only the color, but also the emotional relation, some social meaning.
So that would be a empirical question, I think. I don't think what many people propose, like color linked to language, color linked to emotion, and so on. That's not probably super important, but more to do is color is a local property of the visual field.
Yes.
So many relations with not Nishida-san. Maybe Nishida-san is I mean, at least experientially, the global information also gets into color experience of a particular point, of course. But what I'm saying is that essentially we experience it on that point, and then on that point we have many more dimensional information, at least, and also Qualia is influenced by other Qualia around that point. So that kind of relation is definitely important.
Okay, but you are saying, I'm always confusing. You are saying the relationship, including not only the three-dimensional colors, we have to think about more other property or other modality things. And if so, the brain regions give a playing role for that other modality, diverse everywhere in the brain.
It's not everywhere, right? I mean, for example, for example, B4 or B8, let's say, we tentatively assume that this is very important for color. We know that, they are also related to, color, not only color, but also motion and the texture and the shape and so on, at least locally. And these kind of things that influence the color perception should be also influencing color qualia. That's my guess. But, emotion or language is relatively far in the brain, and its influence is relatively less.
Okay. So that looks very traditional way to dig the brain mechanism. But you are saying often that very more advanced, the scope for digging the concept. So that is what I'm interested in. How can you do for digging that concept? Yeah.
Okay. All right, great. Maybe we can talk a little bit after this on Gather as well. So now please go to let's go to Nishida-san's talk. Thank you very much, Nakauchi-san.
Thank you. Can you see my slides?
Yes.
Okay, so probably will you introduce me or should I start?
Because okay. I just briefly introduce. So Professor Shin'ya Nishida is now in Kyoto University, and he's distinguished psychophysicist, working mainly. He worked for long years in NTT, but now he moved to Kyoto University, and he's been leading to very large grant in Japan on texture perception for like many years, 10 years or so. And today he is going to talk about the insights about color qualia from his research. Please go ahead.
Okay, so my name is Shin'ya Nishida, and today I will talk about the color with the title "Color is not only for color qualia." But this title is given by Tsuchiya-san, so I try to speak along this line. And today I would like to say 3 points about color. And one is the functional roles of color in visual perception. And the other is the dimensionality of color representation. And the last one is the psychophysical measurements of color representations. And the last point is really, the most, I broadly agree completely with Nakauchi-san's position. And what I try to say is probably quite similar to what Nakauchi-san said, but slightly from different viewpoint. And so the first point, the functional roles of color in visual perception. And in a color symposium I heard probably last month, the people are interested in why we have a color perception. And obviously there are a bunch of discussion on the why we have color perception. And some people said that it's functionally very useful to make a discrimination between the fruits with well done or not, and or good to know the healthy condition from the color of the faces. So of course the color is useful to make a better discrimination or a better understanding of the world. But at the same time, I would like to emphasize the point that the color is important for for unconscious inference of underlying physical cause of the image, and our position is based on this classical dichromats framework. Or still, this is working, I think. And the world we have a world here, and that basically, we can decompose those thinking the 3 components, and the lighting and geometry and reflectance or material part, and and through the forward optics, so we can combine this information and make render the image like this. And what vision is trying to do is to infer what happened in the world, in a sense to evaluate these components from the image. And what's the role of color in this framework, right? So this is some example. For example, the color is useful for make a discrimination between whether some X is coming from the illumination or the reflectance changes of the object itself. For example, in this picture, you see that there is a casting shadow here, and but the reason why we interpret it in that way is that there is a luminous difference in this direction, but not the color difference here. Color remains the same. So that we have if color change is typically occurs due to the reflectance change. Of course, sometimes the illumination make a change in color, but in this case, for example, this is a picture taken by, I don't know, the Fred Kingdom or not. But he showed that in this case, although this is actually the light, is in the sun, red sun in the illuminated this part, and actually this is due to the illumination. But we tend to interpret that this is reflection changes, so there is some kind of painting difference between these. And so that normally this is a demonstration he showed that we tend to interpret the color change and the reflectance change and the luminance change and the shadow change. So it's very automatic. And also we saw that what color affects the interpretation of the highlight. And here, you see this part as a highlight, it's easy. But in this case, although this is brighter than the surround, and if this highlight is red over the other colors, and we don't see it as highlight, and something different. And this is because the specular highlight, this is the wavelength and the spectrum, but basically, our illumination is broad, and but diffuse reflections reflects only the limited part. But specular reflections is mainly the mirror reflection. So that this is more like similar to the illumination. So that this situation should not happen in the natural world, and we know that unconsciously, so that we never interpret this one as a standard highlight. And the similar thing is like a wet situation, and this is what we call the wet enhancing transform. But here you see that the right one looks more wet. This is easy to make things wet. And what we are doing is that change some luminance histogram to make it more dark and more glossy. But also we enhance the color saturation here, and the making it more saturated makes us feel that it looks more wet. And probably we never noticed that the wet object is more colorful than the unless you are a painter or artist, that's not very famous fact. But anyone, if you show this stimulus, no one disagrees the point that that looks wet. And the reason why it looks more wet is that due to that. If the object becomes wet, there are more interreflections or more interaction within the object in the material, so that the light bounces more than once, so that wet and just sharpening the tune spectrum and make it more colorful. And also the same thing happened for the more natural situation of the interreflection. And here probably you think that this is the color pinkish, the piece of the cross, but actually this one is, we just removed the color change here, saturation change here. And this one sometimes looks more like you see a kind of the red filter on top of the monochrome images. So you can make a distinction between whether this color change is coming from the object color itself or the illumination change or filter you see. So because if it is due to the object, then there is an increase in the color saturation. But I don't know how good this demonstration works, but this is what I heard from Ted Edelson more than 10 years ago. And also this is color saturation naturalness thing. So this is the original picture, and here we enhance the color and in this direction. And also that we change the luminance contrast here. And probably you think this looks natural. And also this one is okay, and this is okay. But this is obviously oversaturated, and this is obviously undersaturated. So that we somehow know the proper relationship between the luminance contrast and the color saturation, color strength. So that this is more, the unconscious knowledge about the natural image statistics of the world. And what the trick here is that if it is the reflection of the object, the amount of the luminance changes color changes should not be so high. If the color change is so strong that we think that is due to the self-luminance or illumination change rather than the reflection change. So that that kind of knowledge is already installed in our brain. Okay, and the next point is the dimensionality, and so the Nakauchi-san, emphasized the point that color is basically the 3D, but and this is a basic framework for LMS. That is because we have 3 cones, started from the 3 cones. And recently, some people emphasize the contribution of IP-RGC, but I don't say much about this here. But at least basically, we have 3 type of cones and make color opponent stages. And so that in a sense, basically the color representations are three-dimensional. That's everyone believes. But if you look at the cortex, that's actually this color opponency occurs at the level of retina or LGN. But more than that, in the B1, we have more, the hue-tuned neurons, and this is many color people call the higher order color mechanism. And also in a level of IT, there is a more categorical representation corresponding to the color category judgment of human. So in a sense, the color representation are first represented in the 3D, but it is more changing to the high dimensional and more sparse representation in terms of the neural network kind of idea. So that you don't need to think that dimension 3. Of course, originally it starts from 3-dimensional, but the representation become more high dimensional and more complicated. And also, we don't know whether how much we can simultaneously access the information of this hierarchical representation. So that we may, judge, access this and access this, and that awareness system can access both. So we don't need to think it as a simply 3-dimensional. But furthermore, as for the question, this is just a speculation. But what can we consider consciously perceive in color perception? And probably we cannot access from the LMS output, obviously. We cannot access the LMS output as they are, or we cannot see probably the output to the LGN. Probably that's impossible, I think, But probably that we may some access to the mid-level or high-level representation, and we don't know what. And also the language issue, Imai-san's argument that language is important, but of course, the color representations are transferred into the language, but we don't need to think that that's only the final output. And the earlier level representation and color are combined, and probably we can access both. So that probably it's better to think this is something like this is a visual text transformer kind of idea of recent AI, but basically in cortical representation and visual representations and language representations are associated and make a very complicated meanings network. So that it's better to think in the way. And also what's more important thing is for me is that color is not local. That's what now said. But I don't agree with that, because what we see color we see is the color of something. For example, color of surface, or color of illumination, or color of the transparent layers. So there's object, and we assign color. So we should consider color as this kind of property. And also we can assume that the color qualia for different, the surface or illuminations are not the same. So that it's impossible very difficult to match it. Only qualitatively you can match, but you cannot exactly match these two. And so again, this framework, basically color is properties this part or the property of this part. And so the famous thing is the color mode, argument against mode. And this is not a great demonstration. So but what I just want to say here is the brown is spectrally the same as orange. But the difference is that the brown is the surface color, and it never appears in the light. And and many people believe that if the same color is put in the bright context, then it looks like brown. So in a sense, what we see, brown is the object, but we don't see the brown light. So that qualitatively there is an obvious change in the qualia between the orange and the brown. Although spectrally they are the same, locally the same. And also the dress argument, well known this effect, right? And people now believe that the main factor of this ambiguity illusion is that people assume different illumination color. So that some people assume that its illumination is yellow, and some people believe that the illumination is blue. So that in a sense, what you see here is the object color, surface color. So what we are discussing is that a color of this dress, not the color of the pixel, and our perception is based on that one. And also, in more complicated situation is like there is a fog, and we see color of the surface through the color. This is not color, but colored fog, or the more complicated situation. And this is studied in the context of the color transparency. But in a transparency situation, we see both the color of the transparent surface and the color of the surface itself. And so those two color are in a sense dissociated, and we have a multiple color at the same location. So in a sense, the color is not a local property. And also the gold is like this, but it's hard to define the color gold color from only one point. We define the color of the gold. Gold is needs a specular highlight. So in a sense, it's hard to make a clear distinction between the local color and the material. And this is a study from the Commerce Lab, and they show that the spectrally gold and the beige are basically the same, and it depends on the spatial context. And also this is the face color thing, and we think that skin color is the one color, but it's hard to find the best color of me. I don't know. This is, but which one exactly match my face color? So this is also I heard from Ted Edelson, but he showed that the important point is that not only there is a variation, but also that natural skin color requires many colors at the same time. So there should be the spatial variation and the change in color. And that gives us a very natural feeling that, okay, there is a natural skin color. So that you cannot define the skin color by a single point. That's the point. And this is the last slide. And the third point is the psychophysical measurement of color representation. And as Nakauchi-san said, psychophysics have been used the detection, discrimination, matching, and similarity judgment or color naming kind of tasks. And also in the matching, sometimes the people use the apparent match, and sometimes people use the surface match. And this is a appearance thing. But this could be the appearance match. And so appearance is the more straightforwardly they try to in a sense they have to pay some attention to do matching tasks between different objects. So it's in a sense, and depending on whether you want to match the surface component or apparent appearance component. This is also very controversial thing. But this is also very difficult. But sorry. And what I want to say that these psychophysical methods are very low throughput and low dimensional. This is very critical point. In comparison with the recent developed method like the MRI or the multi-unit recordings, and that's a very high throughput, and you get a lot of data at the same time. But with psychophysics, we can only look at the tiny aspect of the big picture. So since the color representation in the cortex are made from the high-dimensional complex representation, but this complex representation cannot be revealed by the one measurement, one psychophysical measurement or one judgment. So that we never say that we don't have Qualia, but the psychophysicists believe that it's not possible to capture everything at once. So that the only we can reliably say is that whether we can detect it, or whether there is a difference between these two, or whether there is how much distance are there. This is a quite local measure, right? So how to reveal the whole view of the color Qualia, and at the same once. So we know local difference like a similarity. And so we should have a very clear view about the task representation and to know how to infer the global structure from local measurement. And so that this is like, the picture, like, this is like a color Qualia, but we can see that only one person can see only the local part, so that we cannot see everything at the same time. So that I think that as, the MDX thing is that, or the representation similarity analysis is a way to overcome this, but we need more data. And so that the use of artificial neural network or GAN to synthesize the image or like a transformer kind of idea sounds like very promising, but we need more data. So the point is that whether we can put a sufficient amount of local measurement to recover all the whole structure of the color Qualia. And I want to say that color Qualia is much more complicated than people normally believe. And so that's basically the point. And also as for the color blind color deficit issues, the important point is that it's easy to say that to ask the people to make a discrimination. That means that whether you can measure the local distance, but this is like you can measure the derivative, but you don't know. In order to recover the original function, you need to know where the absolute location of that color. And this absolute location part is very difficult unless you have two different eyes, and then also the absolute location part is trained. The change can be changed by training, so that in a sense that question is mainly coming from the difficulty of the measurement and the complexity of the target we want to understand. Okay, that's all. Thanks.
Thank you very much. I almost completely agree with what you said, especially towards the end. I guess there are lots of questions, possibly, but maybe, let me see. Do I see that? Is somebody raising their hand? I don't know. I can't.
Yeah, I do.
Okay, yeah, Aniko, yes, please.
Yes, thank you so much. It was this talk was super interesting for me. But one of the things I kept thinking about is have you considered or have you heard of depersonalization and derealization disorder? So depersonalization and derealization is a state where people describe their experience as if they were living in a dream, or if they were kind of perceiving the world through like fogged glass. And the interesting thing is that when people have this experience, they actually describe low saturation or lower saturated images, like less colorful, less vivid. Also, they describe it as less kind of blurry, less contrasted. Also describe it as foggy, and like there's a fog or fogginess in their perception. So it seems to describe or mention some of these complex visual features that you mentioned. And I was wondering if you know of any studies, or if you have thought about this psychiatric condition as a potential example of altered color perception on a higher level. So basically taking or considering realness or lifelikeness as a kind of higher aspect of these or higher dimension for these contrast, blurriness, or saturation variables together.
Yeah, very nice question. And unfortunately, I don't have the specific study. And in our project, Minamimoto-san once tried to see the depression relate. It is said that depression makes everything looks more, less color saturated, and he tried to over the less contrast. I can't remember exactly what he did, so better to ask him directly. But he couldn't find a clear evidence of the changing color appearance or by the kind of the condition thing. And I feel that the difficulty is the difficulty in defining subjective appearance change by the more behavioral methods. And so I don't know, Nakauchi-san, do you remember or? At least it's not easy to define it. Yeah. Nakauchi-san.
Actually, I didn't remember exactly, but the method for accessing the color appearance is just asking the observer to rate the saturation, the amount of the saturation, such things. A very simple way, I think.
So yeah, probably the difficult part is what's the reference, right? So that patient should have some experience before that they had the very colorful word and compared to that situation, right? So always, how to compare it, the change in the color appearance and what's the reference. So if for example, if that patient live in that colorless world throughout her life or his life, so probably there is no way to say that the color is less saturated. And if that change is very rapid in a cycle, like one day or suddenly change, probably there will be that will be a very interesting situation that now want to know what's the kind of brain situations related to the some mental state and some color appearance state. So potentially very interesting direction of the very interesting opportunities to study the appearance representation in the brain. Yeah, thank you very much.
Thank you. And yeah, just to if I can ask another question related to this. So one of the interesting aspects of depersonalization is that people are aware of so they definitely know that, okay, there's something weird happening to me. So they know that their perception changed. And so it seems that people have this understanding of how the world should look like, or how it normally looks like, and then there's a change in this can happen in many ways, induced by drug use or by sleep deprivation, but also just as a clinical psychiatric episode. So do you know, or were there anyone who kind of identified what constitutes as real or lifelike in color perception, or like in our observation of environments? I don't know. It's difficult to phrase this question, right?
Really, we in our new project that want to understand deeper aspect of material perception or shitsukan. That topic you are saying is really related. So that I think it's not easy to control a deeper mental state, a deeper representation of the color. But I think you what you're saying sounds to me a very interesting opportunity to study those things. So I'm very happy if you let me know more about those issues. So and if whether we can do more strict psychophysical experiment on those subjects is a thing. But probably Nakauchi-san have already established some method. And so that's really as I said, we are very much interested in the Qualia or the internal representation, but at the same time we need to do it in a proper way, to study it proper way in an objective way, so that that's always the trade-off. And I think that in particular how to study. Yeah, of course we can use the language description by the subject, but that how to use it, maybe more the data-driven kind of approach may make it possible to make a linkage between the language subjective experience. But yeah, very, very interesting. Yeah, and sorry for not being able to give a proper answer at this stage, but I'm very much interested in the phenomena you reported. Thanks.
Thank you so much.
Okay. Ariel?
Thank you so much for the talk. I thought it was a really good explanation of how color perception or color experience at any point in the visual field is much more than three-dimensional and determined by the context around that point. I guess my question is, like, is there any quantification of like how large an area around a particular point is required to determine what the experience at that point will be? So like with the gold, for example, or with the wet, or with any particular experience of color at a particular point, is there a defined edge to where the context around it matters? Like, is it 1 degree or 10 degrees of visual field, or is it the entire visual field? Or is there some distance at which it stops affecting the experience at any particular point?
Yeah, I think that's a very good question. And the answer is that that context effects cannot be defined in the absolute distance. And so if you, I'm not sure whether I can share this, but sorry. I'm not sure whether I can share this with YouTube or, but
yeah, we can see it. Yeah.
Can you see my?
Yes.
And so this is a demonstration by Ted Edelson, and can you see that, or do I share?
Yeah. No, we can see it. Yeah.
Yeah. Probably you know this kind of demo, right? So that what this demo shows is that the local luminance are affected by not only the local but also the spatial context, and for example, if to define the apparent color, the intensity of the local thing, the very far edges that far away is able to affect. So that it's not only the simple the spatial interaction thing. It's more like how we develop, how we decompose the environment, and which is illumination frame. And it could be very large, so rather than the very local interaction. So I think of course there may be some limit, and because if they are separated in I don't know the 20-30 degree away, the effects may be reduced. But the important point is that there's not a fixed distance that to information interact. Potentially they can interact with probably the number of iterative interaction, but it's more, you should consider it more in a computational viewpoint, and whether we need to decide whether this light source, this luminance component, is how much is affected by the illumination and how much it is affected by the reflectance of the object, and that's very what is called the intrinsic image decomposition. And this part is there are still many computational theory about how to do the intrinsic image decomposition, but that's not cannot be made made easily by the local computation. But I don't know, some people still want to consider it based on the local interaction without considering that kind of high level, the processing. So that it's still the debatable issue. But I prefer to think that the brain is very intelligent and doing very the elegant computation. And even though the edges are far away, we can take into account that one.
But can I ask a related question about this? So most of the demonstration of this kind, or most of the research done, so far is mainly about the visual field around the fovea. and with a display size at 50 centimeter distance from the eye, most likely like 50 centimeter or something like that, with a 30 centimeter display size. So that means roughly like 10 degrees of the visual field out of hundreds and so on of the large entire visual field that we are experiencing. So I think it's computationally also. If we are thinking about V1, V2, V4 IT level neurons interaction, lateral interaction, or feedback across different areas, it's relatively likely that things that are happening on, for example, on one visual field, slightly left to to your fixation, is not really affected by the things on the right field on the periphery, or something like that. But these kind of situation has not been studied almost at all, right? Is my understanding
okay.
correct?
First thing I would like to say is that some fMRI experiments for the luminance filling in had to use the very large field in order to use the better view on the spatial mapping, so that I don't know the exact number, but some experiments use the very big field, like order of the 20-30 degrees, and I don't know whether that how much that scale changes affect the interaction, how much the longer interaction, the distance reduce the interaction is the I don't know, but at least I know that even completely different thing. But for example, if we want to judge the synchrony of the two objects, and we show the stimulus in the very far end of the visual field and the other end of the visual field, but still we see that it's very we are very effective to find the synchrony between the two objects. So yeah, the how much we can compute the interaction of the two information depends on the in case of motion, it's very far, but in case of luminance, it's a little bit shorter, or there's some the difference in the spatial extent that the two information can interact. But in general, at least there are some situations that far separated elements can interact. But you are right, and some people believe that the visual field affects. And for example, attention or crowding, or that is crowding, or those things suggest to be affected by the, for example, difference in the lower and higher visual field, or difference in the left and the right hemisphere, but for the lightness perception, I don't know. I personally I don't know any study to show a difference in the hemisphere or light interaction. So that could be the interesting thing, so I'm happy if you find something interesting.
Yeah. Great. Okay. Is there any further question? If not, maybe I can ask question if it's okay with you too. I mean, it seems like we probably exhaust a lot of time in already discussion within here, so we can probably continue here, and then without going to Zoom, maybe we can conclude, if that's okay. My fundamental question is about the assumption of representation, or veridicality of the representation. So it's a bit of the philosophical flavor. But as a color scientist, or people who have thought about color, I just want to ask both Nakauchi-san and Nishida-san that whether we should actually even invoke the concept of the representation of the world into our head when we are talking about the color. To me, it's already, from the starting point, it's totally nonsense, because the things physically outside of the brain, there's things over there, but of course our Qualia, our experience is something that specifically picks up the particular range of the wavelengths and then combine it in some particular way to experience things for our benefit, which is the part that you talked about in the first part, functional benefits of the color and so on. So from the beginning, I feel the concept of the representing word or veridical representation of the word in terms of color is just misguided kind of notion. What do you think about this?
So Nakauchi-san first or?
Either way.
Nishida-san, please.
Okay, so first, I use the word representation in a more broader sense. So of course, I hate the Cartesian theater kind of view. So that I'm just using a representation in just like artificial neural network sense or any kind of neural network structure that represents something related to color is fine. So I just use the word representation for that kind of thing, and I never define whether the representation is similar to the original image or not. So as long as it works for some purpose or some task, or that representation fine. So I just want to say that my position is similar to you, but at the same time, I would like to. Interesting thing is that these days people tend to prefer the idea of the reconstruction of the image-like representation in the brain these days. Because for example, the predictive coding or the free energy theory or and also that in the graphics domain, for example, in a computer graphics domain, they combine the computer vision and computer graphics at the same time. Because, for example, GAN structure is like the image formation and the image the analysis are working at the same time. So that this new framework suggests, and also the autoencoder of the encoding and decoding framework may correspond to the feed-forward and feedback kind of route. This kind of idea is become very popular in for example, the last week BSS. So my position is that I don't want to believe that we have the image-like representation. We don't need to reconstruct it because that's a homunculus argument that we don't need to see. We don't need to reconstruct to see something. But at the same time, these days the people believe that the reconstruction has a benefit to check a consistency of the many features. So in that sense, that's very interesting, idea that my position right now is very neutral, and originally I don't believe that we need the image-like representation in the brain, but now I think that there must be some benefit to find because the image representation is best to check the consistency of the many processing. And or you can deform it in a more abstract representation in the autoencoder latent space kind of thing. But probably the image is easiest to check the consistency. So that's what I'm thinking.
Okay. And Nakauchi-san, do you have anything to add or?
Okay, about the color science or color, Nishida-san mentioned the color is color of something. So that is very impressive, and that means everything. So, but at the same time, color vision people, they're only focusing on the color, and because by doing this, it is still useful to describe the colors and control the colors of a display or some cards, painting, that thing. So it works somehow, but to understand correctly or deeply the color, we need to think about the color of something, color of the material, color of the object. So, and the color relating to the emotion, something like that. So picking up locally the color, it can be efficient to dig the color things, but still at the same time we lose many things about that. So probably the Nao-san is thinking about that. Only the mentioning the color is nonsense or something. So that is what I want to say.
I should add that I'm not color scientist, so in a sense, my comment is to the color scientists like Nakauchi-san. So
yeah, of course. I mean, the traditional color vision people are always thinking about that, but they are doing what they can do. So, so all of them, or many of them, are escape from that traditional way of thinking. But we needed to develop a new way to measurement, for example. So
yeah, but not only measurement, but I also at some point I want to invite some people who are working on this kind of technique, but local brain stimulation technique such as lift up, low intensity ultrasound, pulsation to the brain of the particular area of the color. I think that may be something that is also interesting to see whether there is some kind of absolute color that Nishida-san mentioned in response to Aniko's comment that even if under the depression or under the depersonalization or so, when the brain is forced to come to this particular state, then they always see this particular color or a particular blackness, a particular whiteness or whatever. Then that kind of activation of the brain and also manipulation of the qualia can be also incorporated to study color. But it sounds like, so far the study has been more or less like, kind of confined within psychophysical observation or device level manipulation.
yeah.
So that would be, I would say, limited. The other point that I also wanted to briefly say is that I'm also impressed by the experiment by Nishida-san on that towards the end you are saying that psychophysics is always local measure, and we are losing the global picture of what the experience is like or color is like, even local or global domain, whatever. But I've been thinking that the mathematical phenomenology or new generation of the psychophysics that we need to develop is somehow like going beyond the local measurement, such as, as you said, the derivative of the surface, to the characterization of the space itself. As long as you are measuring the derivative, like just noticeable difference or matching and so on, you can't get to the entire space. But somehow by doing some global measurement in a massively parallel manner, maybe through the website or the online experiment, we may be able to see whether the surface that we are living is either sphere or donut-like, or maybe in a weirdly curvatured way or something like that. So I think that's on that note. Probably we are thinking along the same line. But do you have any good idea how to get to go beyond the local measurement in psychophysics?
So I think that probably the simulation with the DNN or the artificial neural network or the encoders or analyzing the natural world and see the similarity. It's a kind of an indirect way, but of course it's ideal that we can get a lot of psychophysical data and then combine it into the structure. But we are living in the world, so the natural image statistics is also very important to let us understand what we should represent, and so that these days many people are interested in making a virtual world and put the agent in it and automatically develop in that world. So that kind of work will suggest us that how we should represent the world. And I really expect to relate the linkage with that kind of recent AI type research advancement, and how to combine the psychophysical data with those approach is the kind of a big issues to me. And probably I just want to say that my position is quite similar to yours, guys. So we are not fighting. You don't need to fight each other. We just say that we are nearly in the same position. Only we emphasize quality, or explicitly describe the Qualia, or just say implicitly, I want to do that. Okay, that's the only difference, I think, and not so much different. But one thing I would like to add. Okay, but before that, one thing I would like to add, so that if we lose the color processing, whether we see the black and white world, that's not true, right? So that in order to see for the low saturated images or the black and white images, you need color processing, because you need to know that there's lack of information about color.
Exactly.
That's as regard to your peripheral central experiment or the mental state issues and the low saturated world thing. But as long as they can tell that that's low saturation, for example, their codes should be explicitly indicate that the saturation level, so that that's it's very important. And although, for example, we know that in a long-term experience of the world, our macular structure change and the color change and the white points should change, but we adjust to the environment. And also the many subjects, it is already known that the LM cone ratio changes dramatically across subject, but the perception is the same. So that we have although the signal is changes dramatically, but some compensation is able if the brain try to adjust to the environment. So that I think that what happened in the periphery is interesting, but at the same time there is a good check. Rather, if there is some it's what happened in periphery for color vision is that only that we don't know what happened. So we don't know anything about color. So if we can make a judgment about color, probably that should be based on some information about color at that location. And that can be compensated for or adjusted or trained in some way. So this is a little bit different from the point, but I just want to emphasize that the lack of color, color processing is what we can imagine what happened and what kind of perception would be there.
Wait. I mean, I almost everything I followed what you said, but towards the end, when you said about the extreme peripheral color, are you saying that you would predict that if we present, let's say, a patch of a color that doesn't have any context or object or anything, and that's nothing to do with the central thing, and then you present one color patch at the fovea and then one color patch at the periphery, which is relatively large and visible definitely, you can't even compare the color reliably.
Yes, if there is no information, first, if there is one point is that if there is some residual color processing there, then probably it's possible to match the color between the center and surround, because there is a good environmental information that train the network to learn the proper correspondence of the center and the surround. And if there's no color sensitive pattern there, then probably the judgment of the comparison become impossible. And because one said I don't know, one have no information about color. But at the same time, I'm saying that in that case, the peripheral does not have to be seen as the black and white, because the black and white is also the perception, the color perception. So that I don't know how we see that, or we may use some memory of that object and use that for judgment. And if they are totally unrelated, well, we just say that we don't know.
That's very interesting, because we are going to test that.
I know. So so that I just try to say that what kind of results would be expected, or which aspect you should see. For example, variance of the judgment should be become large if the code of the color become worse. So the point is that variation, noise part, and the correspondence, what's the meaning of that distribution. So I don't think there's a good reason to expect any bias introduced between the central and peripheral, but variance or reliability of the judgment would change. So that's a very simple expectation, I think. And at the end, variance becomes so huge, and you can't tell anything about it.
And your expectation basically comes from the expectation of that the peripheral retina we have much less cones.
Yeah.
Okay, all right.
But at the same time, rod is able to work or contribute to color. And IPLDC could also. So any kind of neural network may be able to pick up a tiny signal about color. So that's also very interesting possibility that how we cope probably Nakauchi may know better and how the rods contribute to color perception in the peripheral. Do you know that?
Actually, 2 years ago, we had a demonstration of extremely peripheral color perception at the conference, BSS, 2 years ago, collaborating with Shin. And that demonstration showed that even in the 80 degrees of the visual angle, we briefly represent, stimulate the LED stimuli there, red and green. And of course, textbook says you can't see any colors, but actually we saw a very vivid red color. But that decision is very less accurate. So even the green light brief presentation brings a reddish appearance sometimes. But anyway, we saw a very vivid color even in the very, very far peripheral region. But not accurately accurate means physically accurate. But perception.
Yeah, that's all right. But I just wanted to make sure that your stimulus was very tiny, right?
Tiny, yes.
Yes. Okay.
And of course, diffuse in the eyeball, eye optics, and may affect the other areas, of course. And the rod may play a role. But anyway, phenomenologically, we could see the color, even in the very.
Okay. All right. Now that it's already 1.5 hour past 1.5 hour, I feel like it's too much to ask you to go to gather, and we are also the audience is also probably have to do something else. So I think today we are closing with this without going gather. And if anybody wants to discuss further individually, I'll be here for a while in the Zoom. So just please, and also in YouTube, if you have any questions, please post it. Thank you very much, Nakauchi-san and Nishida-san. It was very stimulating and interesting.
Thank you.
Yeah. Kianshen, you can stop streaming.
On OBS. Sorry. On OBS.
Did you do that? Yeah, OBS. Yeah.